The topic that I chose for my final project is welding, since I actually have a very high interest in welding and forging and all the lines leading towards that. I actually just started watching Forged in Fire on Netflix, and it has become my new favorite show to watch, mainly because it deals with forging metals and welding and all of that. So there are two major categories, which is fusion welding and solid state welding. For fusion welding, the coalescence is accomplished by melting the two-part surfaces to be joined, in some cases adding a filler metal to the joint. There's such things as arc welding, resistance welding, and oxy-fuel gas welding. I'm going to be focusing on oxy-fuel gas. Solid state welding is heat under pressure used to achieve coalescence but not melting the base metals, and no filler metal is added. Oxy-fuel gas, or OFW, employs with several types of gases. Commonly, it's used in cutting torches to cut and separate metal planes. The most important part is oxyacetylene welding, which is known by OAW. It's a fusion welding process. It has a high temperature flame from combustion of acetylene and oxygen. Filler metal is sometimes added. This is mainly what they use actually on the Forged in Fire show that I watch. They do have two very large tanks that they use in order to come out and weld together pieces of their blades that they have to use. Normally the shape is a rod for the filler metal that goes from 1.6 millimeters to 9.5 millimeters, or 1/16 to 3/8 of an inch. The composition of the filler must be the same of the base metal. It's often coated in flex to help clean surfaces and prevent oxidation. Acetylene is the most popular fuel among the OFW group. There's many more of them, however this is the most common one. It's capable of higher temps than the others, up to 3,480 degrees Celsius, or 6,300 degrees Fahrenheit. The flame is produced by chemical reaction of the acetylene and oxygen in two stages. This right here is stage 1, which then makes stage 2. The combination of these two gases is highly flammable, making the environment that is used in very hazardous. Acetylene is a colorless, odorless gas, but commercial acetylene is processed to have a garlic odor so that those who are using it can tell when there's a problem, if there is a leak. And the cylinders are normally packed with porous filler materials such as asbestos, balsa wood materials, and are saturated acetone. Acetylene dissolves in acetone, making it easier for them to keep it stored. However, it's still dangerous. The welder, if they're going to use this type of welding, must have eye and skin protection such as goggles, gloves, and protective clothing. There's on the canisters themselves, there's different screw heads that are standard and certain hoses so that they avoid accidental connection to the wrong gases. The proper maintenance of these is imperative. They have to make sure that everything on each of these canisters is 100% so that they don't have an issue. The equipment is relatively inexpensive and it is portable. It's actually on a dolly that they can move back and forth, that has both of the canisters on it with different colored hoses so that it can be moved back and forth. It can be mechanized, but it's usually performed manually and it's dependent on the skill of the welder. There are alternate gases that can be used. The one that compares most to acetylene is methacetylene propylene. I'm sorry if I mispronounced that. It's commonly known as MAPP. It can be stored under pressure as a liquid, which is a lot easier than storing it in two big cylinders. There's also oxyhydrogen welding, where hydrogen is burned with oxygen as a fuel. There's propane, but propane is more for brazing, soldering, and flame cutting. And there's natural gas. Those are more common in small welding shops because it achieves a high temperature flame. There's also pressure gas welding, which is a special OWF process. It's a fusion welding process which coalescence is obtained over the entire contact surfaces of two parts by heating them together in appropriate fuel mixture and then applying pressure to bond the surfaces, and no filler material is needed, so it's a little different. That's all I have. Thank you.